So we made it to module 3. Module 3 is going to be a little bit about the pesticides that we can use and also some biological controls for both our insects and for our fungi or our diseases. All right. So when we're classifying pesticides, we also lump herbicides in there, insecticides, fungicides, and then other things like viricides, bactericides, nematicides. There are just a bunch of those ides that can be lumped under a pesticide. And so, that pesticide is, defined as that toxic substance that can kill a pest. And the pest being whether it's a herb, a weed, or an insect, or fungi, or nematodes. So I think it's important for us as, at least in agriculture, just in general, and also as agronomists, to understand both sides of the coin, right? And so I think that we are going to face even more pressure to minimize the use of chemicals in our production system. But if you grow corn on a large scale, or if you grow crops on a large scale, you have to understand that it's very difficult and probably more cost effective. Or costly to manage 1,000 acres and make sure that all your pests are kept in control. So being an agronomist in agriculture, believe that you're going to run into some things where you may be pro pesticide, and you may run into producers that want to minimize that, and maybe it's not even producers; it could be just in general. So having an understanding of some of the things that pesticides are helping us do, especially for these higher crop yields, supposedly lowering food prices. We're at least getting better quality food because we don't have the insect pressure. You know, they're rather inexpensive, relatively, considering some of the other options and alternatives. But on the flip side of that, like, we're also running into some issues with resistance because we've been spraying these insecticides, or we've been spraying these fungicides, especially fungicides. We've been spraying these chemicals for so long that eventually we've developed resistance. And so it's important to understand that you cannot use, or you should not use, the same chemical or the same active ingredient or the same mode of action or mode of entry every time. And I'll give an example: Roundup. We've got Roundup ready. Roundup resistance in a lot of our fields because we sprayed so much of it. Because we didn't use another mode of action along the way, and those plants developed a resistance to that. Our insects are doing the same thing. So there's the pesticide resistance. And sometimes producers are applying this in excess. And again, getting back to this, I don't think that any of us that come through the agriculture program, or being an agronomist, are intentionally trying to produce crops in an unsustainable manner. So we'll hang our hat on these buzzwords like sustainability, but I don't think that anyone is intentionally trying to figure out how they can apply more. Mainly because we're environmental conscious, and we know that that's our future, and then also it's costly. And so agriculture is not necessarily this very lucrative production system. So we were trying to minimize our inputs so that we can maximize our outputs. So you need to make sure that you're having at least an understanding on both sides of this coin as to why they're beneficial and some of the drawbacks that can be with those as well. I think that's with everything. Okay, so at least starting with, if you took my crop production class, we got our certified pesticide applicators license, and this was part of the training that we did. And so it's really hard for me to not talk about at least some of the personal protective equipment, the warning words on the label, because the label is the law, and that's really where you're going to find all of the information. So we've got caution, and caution is like, hey, guess what? You're spraying a chemical that is known to kill stuff. It's probably not very toxic to humans, but don't take your chances. Then we've got warning. And warning is moderately toxic. Like, you should probably have some PPE on, at least long sleeve. I think for any time you're spraying any chemical, that you should at least have closed-toed shoes, long pants, long shirt, gloves, and I think at least those four. Now, do we? Maybe not. but we should, especially as we start getting into, these danger poison words. And so danger is highly likely to cause some either eye damage or some skin irritation. And so don't get this stuff on you. And then we finally have danger poison. And danger poison, you're probably going to see skull and crossbones. You need to take extra precaution for this. And most homeowners who don't have that certified pesticide applicator's license are not going to have access to this. You need that license in order to purchase this at the co-op. So that's kind of where it's important to understand that if you're purchasing this, you need to make sure you're taking the appropriate precautions. Because again, the label is the law, and this stuff is going to be highly toxic, and you need to know that and also be able to demonstrate that to, your producer or your homeowner, or, understand that if you're spraying that in a greenhouse, that like there are, re-entry times, whatever the case may be. All right, so here we are. We've got, these guys are probably spraying something that's danger poison. I mean, they are covered up all around. There is very little access for this chemical to get on their skin. And so if you have to put on a respirator, you're probably spraying something pretty toxic. Anytime you got to put on the chemical suit, and sometimes it might be that you have to put the chemical suit on just to make sure, just so that you don't run the risk. Now, this may be in a different country, and probably back in the 50s. This is kind of how they did it because they didn't really think about, putting on all this stuff. They just went out there and they just started spraying stuff. And so, things like DDT, those ended up causing long-term significant issues down the road. So, you want to minimize your exposure to this. And if you are exposed to it, you want to make sure that you're appropriately covered. And so while this guy is spraying with a respirator, it's possible that this fumigant can still get into his skin through these open areas, right? And so that's where the chemical suit comes in, and you're protected over that. All right, so next, a little bit about pesticide terminology. And so the thing that's most important is the active ingredient. And I didn't want to turn this class into like this thing where you knew what the chemical was, because you can look this up on cdms.net. And that's what the lab's going to be about. So, but what you do need to know is the active ingredient, because when you go into the co-op or you go into Lowe's, you need to make sure that you're getting the right chemical. And something that is different is, there's going to be a common name and there's going to be a chemical name. And the chemical name you're probably not going to know. No one really is, but it's going to be on the label. But everyone will know the common name. And so I always use the example water. Okay, water is the common name. The chemical name is dihydrogen monoxide. You're not going to go into a restaurant and ask for dihydrogen monoxide, right? You're going to ask for water. And so then there's also going to be a trade name. And this can be Dasani, or it can be Fuji, or Great Value, or Members Mark, or whatever. That's the trade name. And now there are different trade names, and not everyone's going to know all the trade names, but everyone will know all the active ingredients, right? So it might be that you don't want, all right, so let's think about this in terms of like glyphosate, Roundup. Many of us know it as Roundup, but there are different trade names because it's come off patent, and your co-op may carry a glyphosate product that is cheaper than the Roundup product. They're both glyphosate, they're just different trade names, right? So glyphosate is the common name. We got, it might be Eraser, it could be Cornerstone, it could be Roundup. Same thing with our chemicals. Same thing with our insecticides. You need to know what the actual like the common name is, so that if you go into the co-op and you say, hey, I need a carbaryl, they'll be able to point you to a carbaryl. And we'll learn about that and like how to like determine that when we do the lab for cdms.net. We got the formulation. How are you going to apply this? This should be on the label as well. We'll see that. So this would be an emulsifiable concentrate. We're going to, maybe it's on a granule or a pellet. And maybe you've seen this. Like if you go into Lowe's and you get, an oxidizone, it's going to come on like this little carrier pellet. The pellet is just the dispersal agent. That's just how to get the chemical into the yard, or, onto the ant mound or whatever it is. The chemical is on that inert carrier, and that's what that granule or that pellet is. Okay, it might be a soluble liquid. It could be a water soluble packet. I'll tell you this story. When I was in college, back in like 2007 or 8, we were learning how to spray fungicides, right? We had a little golf green. We were going to go spray the fungicide, and the instructor told me to go, put it in the tank. And we had been filling the tank up, and there was some water on the tank, and I put the packet on the tank that was water, and the plastic that held it together started to come apart because it's water soluble. So essentially, what you do is you dump the packet, kind of like a Tide Pod, into the tank, and then that's how it gets mixed. So be aware of those things as well. All right, so here we are. We got our chemical name. No one's going to call it 1N-naphthol methylcarbamate, but we will call it carbaryl. And the trade name may be 7. I think that's probably one of the most common insecticides that anyone can purchase. You can walk into Lowe's or Walmart and buy this right off the shelf without any problem. But to understand that there is a chemical name on there, there's a common name that most people are going to know, and then a lot of people are just going to call it 7, kind of like Roundup. All right, so here's another label. We've got our trade name, 7. We've got our formulation, which is a soluble liquid. We've got our common name, and we've got our chemical name and the percentage. This is my rate over analysis, right? This is the analysis. It's 43% by weight. So when we're doing calculations in Module 3, because there's going to be math, that's where you're going to go find the percentage, and that's going to vary depending on whoever makes it and how strong it is. So very important information to understand. It'll tell you what insects that it kills, right? It'll tell you what it works on. And, reading these labels is a pain in the neck. It is not very straightforward. You will have to hunt for it. It's not going to be right in front of your face because they've got a lot of information that they need to put out there. But walking through it and understanding that you need to find it, you'll be able to determine on whether or not this is going to kill what you're looking for. So insect identification, like armyworm, we got ants, grasshoppers, millipedes, we've got ticks, chinch bug, sod wedworm. If you can identify what the insect is, then you can go to cdms.net, type in armyworm, and it'll give you a list of different chemicals that you can use. And then it also gives you, how much you need to put out per acre. All right, here's another one. We've got Lorsban, 4E. The active ingredient is chlorpyrifos. That is the common name. The chemical name is OO-diethyl, all of that stuff. Who cares, right? Chlorpyrifos is what you're looking for because you're going to go to cdms.net, type in this insect, and it's going to give you a list of possible chemicals that you can spray. And look, so typically on the label, this 4E, look, there are 4 pounds of chlorpyrifos per gallon. So it's going to give you an idea of what the analysis is right off the bat. Tells you what the target pests are, how much you need to apply per acre. So like you really don't have to do the active ingredient with the math because they've already got it that you need to apply about 1 pint per acre. All right, so the next thing is going to be like the selectivity concepts. And so how do we pick for this? And if we go all the way back, remember I told you there are different, some insects have, like chitin, they have that exoskeleton that is like a shield. And so different chemicals are needed in order to break through that chitin. It's possible that you need to know the growth stage because you can spray maybe a less toxic chemical early on in the growth stage to kill that insect without having to, get full body dress in order to apply this. So we've got selective or non-selective. And so selective is only going to kill a specific type. Maybe it's only designed to kill Lepidoptera, but it does not work on It doesn't work on beetles. It's skipping me right now what order that beetles fall under. I'll probably remember it in a second. Um, is it Orthoptera? Oh, no. All right. And then non-selective. It's going to kill everything. And so let's think about this in terms of herbicide. Roundup is a non-selective herbicide. It will kill everything. We've got types of selectivity. We've got ecological or physiological. And that physiological is going to be in growth stages. So ecological selectivity, this is going to be like the formulation. And so if we want to do a whole area, then we might use a granule because we can disperse that. Think about just applying like Ronstar to out of a regular fertilizer spreader, just like you would spread fertilizer across your whole yard. You get all the coverage. It might be that you only want to do like spot sprays or seed treatments because you want to minimize the use of that chemical. It's expensive. Timing. Are we going to spray this like pre? And remember, I talked about that whether or not you're going to have systemic or contact. And so are you going to spray this on your plant and never run into the issue of reaching the economic threshold? Or are you going to wait to reach the economic threshold and then spray? And then dosage. And so, do you need a lot of this chemical? Do you need a lot if they're in an early growth stage versus if they're already an adult? We've got species-specific susceptibility to a pesticide. And so, they've done these studies to understand exactly how much they need to apply in order to kill 50% of that population, right? This is the lethal dose, LD, lethal dose 50. What is the lethal dose that kills at least 50% of a population? All right, so how we classify those? We've got the chemical composition, we've got the mode of entry, so how does it get in? And then once it's in, how does it act? We've got the toxicity and then stage specificity. And stage specificity is just, is it a larva? Is it a pupa? Is it an adult? All right. So for our chemical composition, there are organic, both natural and synthetic um, options. And so if you're in an organic situation or, you want to minimize the, you know, maybe you're working for a producer who is more environmentally conscious, you at least need to have an understanding that you can get, you know, organic pesticides. But for the most part, we've got our synthetic and we've got organic. And so for those, we have organochlorines, and you probably can't get these anymore, but it's important to understand. This is like DDT. They've since done away with that. However, and the reason why they did away with these organochlorines is because they're very difficult to break down. DDT that was sprayed in the 1950s still exists somewhere in this world. You've got organophosphates, carbamates, and then pyrethroids. And so understanding, at least these four chemical compositions, everything falls under these four chemical compositions. And what we want to do is we want to use different chemicals at different times, right? You don't always want to apply a carbaryl because they'll develop resistance to that. So having an understanding of, I'm going to spray an organophosphate this year, and then maybe a carbamate next year, and then I want to use a pyrethroid. And it also depends on the insect, right? So some of these compositions are specifically designed to kill specific insects. And there you might run into an issue because you're kind of spraying the same chemical class, but you need to make sure that the mode of action is different. All right, so DDT, maybe you have or have not heard of the book Silent Spring. It's the reason that the Environmental Protection Agency was developed, is because Rachel Carson decided that, there were no more birds because we have now sprayed these chemicals, and the chemicals are in the environment, and eventually they bioaccumulate inside of our larger animals that are eating the insects. So you go to spray DDT on this insect and it dies, and then a bird comes and eats that worm. Well, now the bird has ingested the DDT. And so again, these are very strong compounds, very difficult to break down. Next, we have organophosphates. And so, you'll probably see some of these in Walmart or Lowe's. Very easy to get, very effective. You can see that we've got the common name and then we've got the brand name. If you were to go into the co-op, you would need to know these. Next, we have our carbamates. I want to talk about Temic. I'm not sure if you could even get Temic anymore. As you can see, we've got danger poison with our skull and crossbones. This will kill anything, including small animals, maybe even large animals if you put enough of it out. This one is definitely probably difficult to get a hold of. You probably don't need to be spraying or spreading that anyway. All right, and then next we have our pyrethroids. And so these are typically going to end in RIN or THRIN, bifenthrin, tefluthrin. If you move into this area, you will get more familiar with that. Again, I did not want to turn this into like a memorization class where like exactly what chemical is supposed to kill what. What I want you to do is to be exposed to how to go find the chemical to kill what issue that you have. And if you get into this industry, I know one student is intentionally looking to enter the chemical sales industry. As you get into that, you'll start to know these compounds more, the more that you get exposed to them. If you know the four main ones, organochlorine, organophosphate, carbaryl, and pyrethrin, you're already ahead of the game. Okay, next we have the mode of entry, and the mode of entry is just how does it get in there? So I talked about systemic, and so a systemic is actually inside of the plant. So for our piercing sucking insects, when it pierces that xylem and it gets into the vascular tissues and it starts to withdraw some of that, we've got that chemical in there. So as it goes in, it gets into its mouth, it gets into its gut, and then starts to work on from the inside out. We've got stomach poisons, and so this is going to be more like our contact in that when the insect actually eats the plant material, it's poisoned. And so once it makes it into the gut, that's where it will start to take place. So let's think about this kind of like our BT corn, right? We've got this Cry1A protein that is produced by the Bacillus thuringiensis. It's already part of the plant. When the insect eats that plant, it goes into its gut, starts to proliferate, right? It breaks down that gut wall, and then the bacteria take over and basically kill it from the inside out. We've got contact. And so this can just be, direct contact with insects. And we'll just talk about this right off the bat. Like, what about wasp spray? As soon as it gets in contact with that wasp, it's dead, right? Hopefully, most of the time, some of the time. That's why it's got that very long shooting range, right? So you can be away from it just in case if it doesn't. Something for me is that I'll go get like some Bug Be Gone, and I'll spray that around my windowsills and I'll spray that around my door frames so that when the insects are trying to get in, they come in contact with that insecticide. And then we have fumigants. And so the fumigants are probably going to be more in a greenhouse situation because you got to think about trying to spray the fumigants out in the middle of the field. It may or may not be windy. But those are going to get into the tracheal system, and it'll circulate into the hemolymph and gets absorbed by the body tissue, right? So the fat body. So, it's going to come into the tympanum or the trachea, and it's going to get in, like, think about breathing that in. So that's why it's important to understand if your insects have that, because if you don't have a trachea, then why are you spraying this insecticide? Why are you spraying this fumigant? Next, we have the mode of action. And so this is actually how. So this is what This is what. This is how. This is where. So it's either going to be a physical poison, it's going to work on the nervous system. We've got protoplasmic poisons or chitin inhibitors. And so let's think about this. We talked about the chitin as the exoskeleton, right? And if you break down the production of that chitin, then now that insect does not have its protection, and now it's susceptible to attack by others. Or it could be that we're just going to go ahead and completely dissolve that chitin, and now it's just exposed to the environment where normally it wouldn't be. All right, so this is going to kill some physical harm. We've got oils, tar oils. It's pretty much just going to asphyxiate those insects. And so you're like seven. You're going to put that seven dust on them, and those little dust particles are actually going to get breathed in, and then they'll die by asphyxiation. Plus, also that carbaryl has some activity as well. We've got nerve poisons, and so this acetylcholinesterase disrupts the nervous system. And so these are organophosphates and carbamates. Guess what? Guess what? That also works on humans as well. And so it might be that you see these old timers, you might see these old producers, and they've got this nervous twitch that they just can't stop. And so the person who did my pesticide certification, when he was writing on the board, his hand trailed and he couldn't do anything about it and he had to pull it away. But he would write, and then as he got to the end, it would trail off. And so if you spray a lot of these organophosphates, then you have been exposed to this acetylcholinesterase, and that is what's like disrupted that nervous system. And so the same thing for the insect, and then it would disrupt that nervous system, and they would basically just go into convulsions and shake to death. We've got chitin inhibitors, and so for our amorphous, the ones who do not like ametabola, the ones who do not like, they just grow out of the stage. If they can't produce the next growing season's shell, then they'll die. And so that's where having an understanding of what type of metamorphosis is important right there. Protoplasmic poisons. These are going to be arsenical compounds. They're going to cause some protein precipitation. And so if the insect is ingesting a material and it cannot get the necessary nutrients or proteins out of that, then it's going to cause an issue. And then that insect will not be able to make a protoplast or this midgut epithelium. So if we're thinking about this, like this protoplasmic poison would be our BT corn, right? Because that midgut epithelium is going to get destroyed by the cry1a proteins, and then also by the bacteria. On the label, we're going to have our poison, and this also might be a material safety data sheet that you're responsible for. This talks about the lethal dose. So 1 milligram for every kilogram will kill 50% of the population. And then finally, stage specificity, right? And I really just put this in here to talk about that stage specificity. I don't necessarily know that you're going to run into someone who's talked about putting out an ovicide or an adulticide, but just those IDEs are going to talk about like what stage you're actually applying this. So if you're applying a larvicide after it's an adult, it's probably not going to do very well. An adulticide when it's a larvicide, maybe you can get away with that, but not recommended. Next, we have timing. And so we're going to have seed treatments. We're going to have, maybe pre-plant. We're going to put this pesticide out before we plant because maybe it's an insect, like it's a soil insect. And we know that we're going to run into issues with that. And so we're going to go ahead and get ahead of the game. And then we could do at planting. And so you might do this as an in-furrow application. There we go. We've got in-furrow, and then maybe a side dress where, like, after you come back, because if the seed hasn't sprouted yet and the insect life cycle hasn't taken place, then what's the point in putting out the insecticide? But you might know that when you're at, I'm just going to use corn, when you're at V5 or V6 and you're adding your side dress fertilizer application, that maybe you want to go ahead and apply an insecticide as well because you're already running down the row. So there's no point running over the field twice. So you need to have an understanding of when these insects are going to be attacking your plant. And then it might just be broadcast. And, this is probably more for homeowners. And I use the Oxidizon or Ronstar. You're going to get this from Lowe's. And you're going to put it in your spreader, and you're going to spread it across the lawn. And then that chemical will get dispersed and kill any insects that you might have. All right, so let's just take a look at this. We've got our fall armyworm, especially for our corn plants. We're going to run into this a lot. You can see that there are a lot of chemicals in different chemical classes that you can use. And again, I don't really care that you know that diflubenzuron is Demelin, because if you get into that industry, you'll start to get familiar with the content. And so then just a little more, we've got these different materials, 7, it's a carbamate. We've got a pyrethroid. It targets stink bugs. When we go through cdms.net, you can actually type in the insect that you have, and it will give you this list. And so that's the importance of showing you this. And that's why you don't need to memorize it, because you can go find it. You're just going to have to go look for it. Okay. So I'm going to go ahead and cut this video short because it's about 30 minutes. And in the next little module, there's just a couple, you know what? It's not going to be that much. I'm going to go ahead and run through it. All right. So not only do we have chemicals, but we've also got biological controls. And this is going to work really well in like a greenhouse situation, in that you don't want to spray chemicals inside of your greenhouse. And so if you can have beneficial insects, why not? Because you're saving money on chemicals. So we've got importation. And so we recognize that maybe some foreign country has has this particular insect that we want, and so we'll bring that in. We've got augmentation. If you're into entomology and you know what insects like other insects, well, then you can like go back and look and say, hey, you know what? If we put more of these two insects don't like each other, and we're having a problem with insect A, let's put insect B in the ring and we'll let them duke it out, and insect B is going to win. Here's the big problem. Here's the big problem in that there are, like, before we started doing monocultures, insects had their own little balance. They had their own ecosystem and diversity, and that was kept in balance by beneficial and non-beneficial insects. And so when we started spraying more insecticides, we also started killing off the beneficial insects. And so this is where you might run into an issue with conservationists who don't want you spraying chemicals, because you're also killing the good insects. Because remember, we can have selective or non-selective. And if you're selecting for a specific family or a specific order, generally that compound works on that whole order. All right, so we've also got 3 classes. We've got predators, and this is going to be an insect that is specifically looking to find aphids, like our ladybugs is a predator. Ladybug is a predator. It as soon as it finds its prey, it's going to go start eating all these little aphids. I think as children, we probably didn't like insects, and ladybugs may not have been cool. But I think once I got into agriculture and I found out that they were beneficial like that, I was like, oh, we need to make sure we keep those. We've got parasitoids in that, and we'll talk about this in a moment, in that we're going to have this wasp that lays its eggs inside of this Lepidoptera species, and those eggs are going to actually hatch, and the young will feed off of this Lepidoptera. And then, much like our plants, we've also got insect pathogens, and that insects are susceptible to getting sick as well. All right, so entomophagus, again, that is going to be our ladybugs. I think at the time when I was making these, I really just wanted to get an increase in vocabulary, but I don't think I've ever heard them talk about entomophagus. Uh, so you you know these can generally live on several species. So if you got ladybugs in your greenhouse, it's not only the aphids that they're killing; they might be after whiteflies as well. Some examples: we've got our ladybugs, we've got our lacewings, spiders. I think I don't really know how many daddy longlegs we have. I hadn't really seen a whole lot of those in Mississippi. They're all over the place, and so as kids, you're like, "Oh my God, this big spider!" But it turns out that you actually want those in your house, at least the daddy longlegs, because they're killing like any of the little bugs. Now, I don't know that I want a brown recluse or a black widow in my house. That's a little different, but there are some examples. You know, there are some beneficial spiders. As I mentioned, we've got our parasitoid wasps, and they're going to lay those eggs in the body, and then that gets used as food for developing larvae. And so, you know, there are different types of wasps that attack different types of insects. And again, if you get into this, then you'll know which ones you actually need. So it's not a one insect kills all. They're actually species specific. Knowing which species will help you understand which biological control you need to get. So here's a look at that. We've got our parasitoid wasp that is going to lay the eggs inside of this worm. As that, as those eggs hatch, they will then start to feed on the insect from the inside. They'll start to eat that fat body. Here we go. Here's a look at this. This is how you know we're working here. We've got those eggs that have been laid, and this thing is probably not having a good life right now. And so here's a look at a graph showing how much that when you enter this biological control agent, how quickly the populations drop off, especially if you have a larger biological control population than you do for your number of pests. And so then that will go back and forth a little bit as the life cycle of that pest um, if you can get the life cycles timed, but that's not going to be good as well, right? Because you actually want those a little offset because you might have multiple life cycles of the actual pest. And if you have a biological control, beneficial insect that has killed off that population, well, then you kill off the population of the biological control because there's no food source. As there's no food source, the biological control dies. If the biological control dies, that now leaves a gap for the actual pest to repopulate your crop. There are some beneficial nematodes that are going to attack some things. We don't really talk about those too much, and they're not overly studied. I think that's probably more so that when you hear nematode, you're probably thinking something bad. And so we also have to watch a little bit about the nuances of whether someone is going to be okay with you putting a nematode out there. So this is where you need to be a little more educated and say, listen, this is actually a beneficial insect that kills root knot or cyst nematodes or reniform or whichever. These nematodes will kill grubs. So the grubs are going to be underneath, like this is especially for our turfgrass people. Um, if you pull back a patch of turf and you see these grubs and you have these nematodes and you don't want to spray the chemicals, you could apply the nematodes intentionally. And what they'll do is they'll actually infect the grub instead of a plant. And so, you know, within 48 hours, they get blood poisoning because this uh, symbiotic bacteria that is carried by the nematode injects that into the grub, the larva, and kills it through blood poisoning. We can also use these for maybe the diamondback moth, cotton bollworm, or white flies. Next, we have our bacteria. We talked about this. We got our Bacillus thuringiensis. These are mostly going to work on, Coleoptera was the beetle. There we go. Coleoptera was the beetle. So BT is going to work on those orders that actually chew on the plant. And then finally, we have our entomopathogenic fungi. And so these fungi will attack these insects, and those spores will produce. They're going to germinate on the surface and they'll grow all over the body, just like they do all over our plant. And they'll basically suffocate that insect just like they would kill our plants. And again, all these biological controls have generally are species specific. And if you know what species of insect that you have, then you can probably just Google, again, just Google which of these different species of fungi that you need in order to combat that. All right. So that's going to end it for at least the introduction to pesticides and our biological controls that we can use for insects. In the next module, we'll talk about fungicides and their modes of action. And they're a little bit more intricate because those fungi are always adapting. All right. So we'll see you in the next module.